There is growing public interest in low-calorie alternatives to sugar. Synthetic sweeteners are often regarded as having an undesirable aftertaste. Recent publications have shown a dramatic increase in attention toward natural sweeteners, including extracts from the stevia plant. These extracts are over 300 times sweeter than sucrose-based sweeteners. Other health benefits have been attributed to the stevia plant, and recent studies conducted by the World Health Organization have established the safety of stevia and its glycosides for human consumption. The major sweetening components in stevia are stevioside, rebaudioside A, rebaudioside C, and dalkoside A. HPLC and LCMS are analytical tools to characterize the composition of stevia extracts. Asenis Express fused core columns provide the efficiency and selectivity to enable reliable characterization. The purpose of this short study was to look at two different chromatographic modes, reverse phase and Hillock, to characterize stevia extracts using LCMS. In reverse phase mode, C18 is the most popular bonded phase. However, when dealing with highly polar compounds, a polar embedded stationary phase is often more effective. One of the most common polar embedded phases is the RP amide. Polar embedded phases can enhance retention of polar compounds, but it is not always a solution for all applications. Often highly polar analytes require alternative modes of chromatographic retention. In particular, Hillock chromatography allows for alternative selectivity by utilizing a highly polar stationary phase with a relatively non-polar mobile phase. More polar analytes will partition more into the surface solvent and be retained longer than a less polar analyte. In both cases, we prefer to use Asenis Express fused core columns for their high efficiency, fast separation, durability, especially important with natural product analysis, and the fact that the columns operate on any HPLC system. Figures 1 and 2 represent the total ion chromatograms for the stevia extract under both Hillock and reverse phase conditions. Both of these chromatographic separations demonstrate the complexity of the stevia extract. The table shown here lists the major components that were common in both the reverse phase and Hillock separations of the stevia extract. More than 250 components were identified with this comparison, but only the major components were targeted in this study. The highlighted components in the table depict co-retention of analytes under reverse phase conditions. A good example using this orthogonal approach is observed in the case of steviobioside and dalkoside A. Using the reverse phase separation, these components were co-retained. By performing the separation under Hillock conditions, steviobioside and dalkoside A were well separated. The data in the table also depicts the selectivity difference between the two chromatographic modes. Polar components that were poorly retained in the reverse phase conditions were strongly retained under Hillock conditions. Asenis Express fused core columns are well known for providing very rapid, highly efficient separations on any HPLC or UHPLC system. Asenis Express columns are available in many different phase chemistries, so you can leverage the power of bonded phase to improve resolution. The Asenis Express RP amide and Asenis Express Hillock are a good pair to use for orthogonal selectivity of polar compounds, like the stevia extract in this short study.